Hello Internet, with this video we begin the second lesson of your 11th grade physics textbook. And in this video we will be taking a look at the concept of rest, motion and point mass. So the topic of rest and motion depends upon your frame of reference. By which I mean that it all depends upon how you observe the world. For example, you're standing inside a moving bus and you see that everything outside the bus is moving but everything inside the bus is stationary. This is because your frame of reference is the bus. And this also happens to be the only way to find out whether an object is moving or not. We have to compare that object with an object which we know for a fact is stationary. For example, you are standing still on the ground, and for every other person on the earth, you are stationary. But the astronauts on the ISS are moving away from you at a velocity of 7,660 meters per second, which is 21 times faster than the speed of sound. But why am I saying that they are moving away from you? It can very well be possible that you are moving away from them. This is because the objects which are known to be at rest can be considered as frames of reference for moving objects. And in this example, Earth is the object which is known to be at rest. So that is why I said that the astronauts are moving away from you and not the other way around. Now this is one of the basic ideas behind the theory of relativity. In relativity, we consider moving objects with their perspective and their frame of reference alongside with time. In simple words, this idea of relativity is just the science of moving objects and what they experience while in motion. And yes, none of this is in your textbook. I'm telling this just because this way you would actually learn something. Okay, but when we talk about motion in terms of classical physics, then there are a bunch of them, like linear motion, rotational motion, circular motion, vibrational motion, etc. Where linear motion is a motion in a straight line, rotational motion is the motion around an axis, circular motion is a motion of an object around a fixed point, and oscillatory motion is just to and fro motion of an object. I will be giving a detailed explanation in the upcoming videos. But why in the upcoming videos? Why not now? It will be a waste of time for both you and me. And by the time we learn about something which actually makes use of these topics, it's pretty likely that an average 11th grade student would forget almost all of it. And going through a bunch of videos just to recall about something learned earlier is also a waste of time. So yeah, I will be giving a detailed explanation about all the above mentioned topics in my later videos. But for now, let's learn about point mass. Well, it's just a way of making the work easier. And by work, I mean math. We consider massive objects like the Earth as a single point in space so that analyzing the orbit of the Earth around the Sun becomes much easier. And when we consider Earth as a single point in space, we make sure that the point has the same mass as the Earth. It's kind of like calculus. It's not calculus, just kind of. Where we reduce something really big into something really tiny, and then we use this tiny thing to make the necessary computations. And when we get the results, we convert them back to the original form just because it makes the job much easier. And we only get an approximation of the actual value. But this difference between the actual value and the approximation is negligible. And that's why we consider huge objects like the Sun and the planets as a single point in space, so that we can simply and easily calculate the motion of planets around the Sun. A perfect example would be a black hole, which has all its mass compressed down to a single point. And until recently, we did not even know that a black hole even existed. At the time of this video, it was only a few months ago that we humans were able to find an actual black hole and take the first picture of it. But we still were able to predict its existence. And how did we do it? It's that we humans are simply great at making stories. We think and make many different stories, but calling them stories doesn't sound right, so we call them theories. And when we have a lot of them, we use the one which best suits the situation. We did the same with the black hole, and almost about every other thing in the universe. So start building stories of your own, and hope that one day they match with the reality.